good day. By the way, my name is Navarro Siriga Plaza.
I'm Emily Gato.
I'm GNC Tenebroso and we are the Group 10. Today we are here to talk about how to determine the number of diagonal in a polygon.
But first, let's identify what is a diagonal and a polygon. So what is a diagonal? A diagonal of a polygon is a line segment that connects the vertices or corner of a polygon, or in the other words, it's a straight line connecting the opposite angles of a polygon through its vertex. While a polygons are plane figures having at least 3 sides, and usually it is used to identify figures having 5 or more end angles. But before we'll start our discussion, let's first have some game or an activity. As you can see above, the following are some example of a polygon. So we have a triangle, quadrilateral, pentagon, and hexagon. So my first question is, how many do you think are the number of diagonals found in a triangle? I'll give you 2 seconds to answer. Time's up! Yes, exactly, you are right. There are no diagonals found in a triangle. But why? It is because, as we all know, diagonals are line segment that connects the vertices or corner of a polygon. And as we all know, a triangle is the simplest form of polygon, and it has no diagonals because we cannot draw a line across the corner of each side. Diba? 3 sides naman ng triangle, and we cannot draw some lines that can connect into the other corner. So therefore, the answer is no. The triangle has no diagonals. The next one, we have the quadrilateral. Do you think a quadrilateral has diagonals? Again, I'll give you 2 seconds to answer. Time's up! Yes, you are right. There are diagonals in a quadrilateral. But how many diagonals can be found in a quadrilateral? Do you have an idea? Okay, let's start to count. So we have here 1 and 2. So therefore, there are only 2 diagonals can be found in a quadrilateral, since we can only connect 2 lines in each corner. So the answer is yes, and there are 2 diagonals can be found in a quadrilateral. The third one, we have the pentagon. So as we all know, pentagon has 5 corners or angles. Do you think there are many diagonal lines in a pentagon since it has 5 corners or angles? Do you have an idea on how many diagonals can be found in a pentagon? Now, I'll give you 10 seconds to answer if how many diagonals can be found in a pentagon. And your time will start now. Time's up! So now let's find out if your answers are correct. So let's put now some lines in our pentagon and let's find out if your answers are correct. So we have 1, 2, 3, 4, 5. Do you see another corners nga wala pa yung lines? So I guess wala na, diba? So therefore, pentagon has only 5 diagonals. Correct ba yung mga answer? I guess yes. Now let's move forward to the last example. So we have here a hexagon. So when we say hexagon, it has
6 corners or 6 angles.
Now, let me ask you, how many diagonals does a hexagon have? Do you have an idea? Okay, again, I'll give you 10 seconds to answer. Time's up! Yes, you are right. There are 9 diagonals in a hexagon. But why? Okay, let me show to you Why does a hexagon has 9 diagonals? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Can you see another corners nga wala pa nabutang yung line? So I guess wala na. So therefore, the answer is 9. There are only 9 diagonals in a hexagon. I think you are now ready to our discussion. But I want you to remember that the formula to get the diagonal of a polygon when it comes to number is d equals n times n minus 3 divided by 2. D represents diagonal and n represents the number of sides of each polygon.
In this part, it particularly answers or explain the content of the table. Kung nalibgan mo, so di ara ang explanation. So, we have here the formula. D is equal to n times n minus 3 divided by 2, where n represents the number of sides in a polygon. Now, let's try with a triangle. Triangle has 3 sides. We all know.
Now 3 minus 3 is 0, and 0 times 3 is 0, and 0 divided by 2 is 0 also. The red lines here represent only the sides. So dili siya diagonal. Sides na siya sa triangle.
So in this figure, there is no diagonal. Therefore, triangle has no or 0 diagonal. Now let's talk about the four-sided polygon, like quadrilateral, square, rectangle, rhombus, trapezoid, and a kite. Okay, so
in this case, n is equal to 4. Let's use this formula again. It's going to be 4 times 4 minus 3 divided by 2. Now we have 4, then 4 minus 3 is 1, so 4 times 1 is equal to 4. 4 divided by 2 is equal to 2. So starting with this point, we can draw diagonal to this side. That's 1. And starting this point, we can draw another diagonal. So there are 2 diagonals that we can draw for a four-sided figure, such as quadrilateral, square, a rectangle, a rhombus, and a trapezoid.
The next one, we have the pentagon, which is known to have the 5 angles or 5 corners.
Number of sides is 5. So we have 5 times 5 minus 3 divided by 2. We will get 5, then 5 minus 3 is equal to 2. We can cancel the 2 and 5 diagonals we can draw. Starting this point, we can draw 1 here. We can also draw 1 here. That's 2. Now we start this one. We can draw 1 here and 1 there. So that's 4 so far. And we can connect those 2 points. That's the total of 5 diagonals in a pentagon.
now what about a hexagon? How many diagonals can we draw in a hexagon?
We all know that hexagon has 6 sides. So it's gonna be 6 times 6 minus 3 divided by 2. 6 minus 3 is 3, and 6 times 3 equals 18. 18 divided by 2 is 9. So we'll start in this point. We can draw 1 here. That's 1, 2, and 3. Now this point, 4, 5, and 6. Now starting this point, this would be 7 and this would be 8. And if we start here, this will make 9. So there are 9 diagonals that we can draw for a hexagon.
We're done with triangle, quadrilateral, and hexagon. Okay, so now we're going to proceed to heptagon. How many diagonals do you think can we draw in a heptagon? So let's find out.
In this case, this is gonna be 7 times 7 minus 3 divided by 2. Now 7 minus 3 is 4, And 7 times 4 is 28. And 28 divided by 2 is 14. Let's see if we can draw 14 diagonals. So this is 1, 2, 3, and 4. Now starting this point, 5, 6, 7, and 8. Let's move on here. 9, 10, 11, and now starting this point, this is 12, 13, and the last one, this is 14.
So we have 14 diagonals in a heptagon. Now let's move on to octagon. Okay, so pila na sad kaha ka diagonals, number of diagonals ang naa sa octagon. So let's see.
We will use again this formula. D is equal to n times n minus 3 divided by 2. For octagon, n is equal to 8 because there are 8 sides. So that is 8 times 8 minus 3 divided by 2. 8 minus 3 is 5 and 8 times 5 is 40. So 40 divided by 2 is 20. So let's see if we can get this answer. So we will start in this point. So this is 1, 2, 3, 4, and 5. Now starting this one, this would be 6, 7, 8, 9, and 10. Now let's move on to this point. 11, this one 11, 12, 13, and 14. Starting to this point, we have 15, 16, and 17. Sorry, hiwi kayo. So, this gonna be 18. This one, kanang yellow line, and 19. The last one is this one. Kani siya kani. So, we have 20 points, 20 diagonals in an octagon. Now, if we will continue finding the numbers of diagonals in a polygon, we can have 27 diagonals for a nonagon and 35 diagonals for a decagon.
My group Miss Emily Gacco showed to you on how to calculate the number of diagonals of a polygon using a formula which is the D equals n times n minus 3 divided by 2. And now I'm gonna show you on how to determine the number of diagonals in an heptagon and an octagon using a sequence. As you can see, we have here a table. The table contains the number of sides and the number of diagonals. So let's first have the number of sides. So we have 3 here from the triangle. Since triangle has only 3 sides, then we also have 4. Since the quadrilateral has 4 sides, then we have 5 from the pentagon. We have 6 from the hexagon, and then we have 7 from the heptagon and 8 from the octagon. And the other one, we have the number of diagonals. So we have 0 from the triangle, since we know that triangles has no diagonals. We have 2 from the quadrilateral, we have 5 from the pentagon, and we have 9 from the hexagon. Then we have 2 blanks here from the heptagon and octagon, since we still need to determine the number of diagonals of its polygon. So now let's apply the number that is found in the table. So first, let's copy the given number from the diagonals, which is the 0, 2, 5, and 9. After this, we need to add another number to 0 so that we can get the number 2. And the possible number that we can add to 0 so that we can get the number 2 is 2. Then after, we need to add another number to 2 so that we can get the next number, which is the 5. And the possible number that we can add to 2 is number 3, so that we can get the next number 5. And then to get the next number 9, we need to add another number to 5. And the possible number that we can add to 5 is number 4, so that we can come up with the number 9. Now you can already see on how we get the number of diagonals from the triangle to the hexagon using a sequence. Now let's continue the sequence so that we can get the diagonals of the heptagon and the octagon. So now let's add another number to 9 so that we can get the next number, which is the heptagon. And the best number that we can add to number 9 is number 5. Maybe you can already figure out that we only add 1 to the following sequence so that we can get the diagonals. So 9 plus 5 equals 14. Therefore, the diagonal of heptagon is 14. Then the last one, to get the diagonal of an octagon, we need to add another number to 14. Since we only add 1 to the following sequence, so 5 plus 1 equals 6. And the possible number or the best number that we can add to number 14 is 6. So that we can come up with the number 20 because 14 plus 6 equals 20. And therefore, 20 is the diagonal of the octagon. Since we only add 1 to the following sequence to get the diagonals, now let's put number 1 to the following sequence so that we can make it clear that we only add 1 to the following sequence. Thus, the pentagon has 14 diagonals while the octagon has 20 diagonals. To clarify the result of the following sequence, we can create some polygons that shows the heptagon and an octagon and count its diagonals. Let's first count the number of diagonals in a heptagon. We already have here 3 diagonals. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Therefore, our sequence are correct. Heptagon has 14 diagonals. Now, let's move forward to the octagon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this means that our sequence is correct. There are 20 diagonals in an octagon. That's the end of our report. Before we say goodbye, let us share to you some inspirable quotes to make you inspired. Math may not teach us how to add love or subtract hate, but it gives us hope that every problem has a solution.